One of the probably most important things that you need to learn, maybe one of the more difficult, is the idea around package design. Go decided to change things up a little bit from other languages and bring in this concept called packaging. So let's talk a little bit about the history of where packaging comes from. Then I'm going to get into some mechanics and semantics around it. And then eventually I'll show you some examples of how we use packaging in Go, and also start talking about things like policy and other stuff that's going to be important to help you with your mental models of your code base. So I have this idea around package-oriented design, and it's something that every Go developer has to develop on their own. There is no one way to architect and design your Go projects, like it would be in any language, but the idea of packaging becomes important. So for me, package-oriented design really means three things. It means here that you've got to be able to identify where a package belongs in your Go projects. You've got to be able to kind of define what a Go project actually is and how it's structured. It's something that we don't really get guidance from the language itself. And then finally, you gotta be able to communicate as a team what clean package design really means. So we got to be able to have a structure and have a design and a philosophy that promotes that clean package design and architecture, and have real engineering conversations around it. And I don't want to be in a situation where on Monday you identify you need a package and you put it here, and then on Wednesday it would have gone somewhere else, because you don't have these real clear idea of how to structure your projects and where things should be. It's going to hurt you and your mental models of your code base if we don't do this. But to give you a little history, here. There was an interview 19 years ago, in the year 2000, where Brian Kernighan was asked, can you tell us about the worst features of C from your point of view? And when I read his response, I almost fell out of my seat. This was a few years ago. And Brian says, I think the real problem with C is that it doesn't give you enough mechanisms for structuring really big programs, for creating firewalls between those programs. And it's not that you can't do this, right? He's saying that you can simulate object-oriented programming or other methodologies you want in C. It's not that you can't do it. But the real problem is that the language and the compiler aren't there to help you. And when you hear Brian's kind of answer to that question 20 years later, you start to realize, wow, this is what Go was trying to accomplish with packaging, trying to create this idea of firewalls within these programs where the compiler and the language is there helping you. So let's talk about the base language mechanics here, and then we'll get into some design philosophy. So here are the base language mechanics for packaging in Go. And the very first thing that's going to always jump out at you, it jumps out at me, is that this idea of packaging really conflicts with the way other languages do it. And that's primarily because the idea of packaging is that within the scope of your project source tree, we're not using folders anymore to organize our source code. Folders are really the organization of APIs. And the idea is that the entire app is built around a set of very clear and static API sets. So we could think of packaging as components, or folders as components. We can think of folders as static libraries, even microservices, right? This idea where there's this very thick division between one set of code and another. So the folder in Go is really the basic unit of compilation. We have to remember that. We talked about that a little bit when we were talking about exporting and unexporting. And this really is a new idea in terms of application design. All right? You're not designing this monolithic app anymore, where the folders represent some sort of mental model of where source code files are. You're literally organizing your entire app based on a very clear set of packages, again, static libraries, components, whatever word helps you there. And so what you have to remember is, even though we might have a hierarchy in the source tree, there really isn't the concept of sub-packaging. Just because an API is listed underneath another API doesn't mean that's a sub-package. It just means that's where it is physically in the source tree, and that's supposed to help us with our mental models to find something. Because at the end of the day, every folder will get built into a static library, and all those static libraries flatten out and then get linked together to build that final app. We talked about exporting and unexporting being ways of opening up those firewalls based on those things that are named. And one other interesting constraint here with the language mechanics is that two packages can't cross-import each other. So the import paths have to be very, very clear. That makes you slow down, really, because you've got to think about that dependency that you're creating. And these types of dependencies cost you a lot. And the other nice thing about not having the cross imports is that initialization should be a lot clearer, because initialization happens in the order, right? In that order that these imports are going to be locked in from lowest to highest. So it gives you some very clear and clean initialization. It also makes you have to slow things down and really think about the dependencies that you're creating. So we've got these language mechanics that we've listed out. They're not a lot, but they are there, and the compiler's helping us. Let's quickly talk about some of the design philosophies here. And these design philosophies that I'm going to share with you are in general accepted by the majority of Go developers here in the Go community. And these are good philosophies to kind of have in place while we're thinking about what makes a good package and what doesn't, where does it belong, all of these things that we'll talk about. So for me, there's three aspects of the design philosophy for packaging. One, package has to be purposeful. It has to have purpose. So if you come to me and you say, Bill, I need a package, I'm going to ask you, what is the purpose of this package? Can you clearly define what its purpose is? And if you're not able to do that, and it starts to become an idea where it's a package that contains things, we're probably going to be in a lot of trouble. You can have packages that contain things, but you have to be very clear when you're doing it, and they have to be in very specific places in your project. So as a general guideline, we want packages that provide and not contain. So packages like FUMPT and NET and OS, these are great packages that are providing. And just by hearing the name, you know what they're providing. Packages like utils, helpers, one of the worst packages you can have, models, where you're creating a package of just of concrete and interface types. Really bad mistakes from a Go perspective. We really want every package to kind of be its own island here. The more every package is its own island, the less a package imports, beyond the standard library. Really, the more flexible that package is going to be. So we're going to be looking for these things here, and we don't want containment. We want purpose. And again, there are exceptions here and there, but if you've got these packages that contain, models being one of the worst, then everything's going to be built on top of it. And at some point, you're not going to be able to change your type system or change something, because the cascading code effect will be so great that you're just going to have to hold back. And eventually, at that point, your project is staled. Now, we could talk about item 2, which is usability. A package has to be designed with the idea that a user is going to be using it, right? And we've talked about some of these things, right? We're writing APIs for users, not for tests. So usability is huge. And we've talked about some of these things along the way in this video. Intuitive and simple to use. You got to make sure APIs are respecting the impact on the applications that are being built. We've got to minimize those cascading changes throughout a code base. Again, usability is there. We want to stay in that decoupled state when we can, right? When it's reasonable and practical. And we always want to be focused around that idea of reducing, minimizing, and simplifying code bases. So usability is something that we're going to get in those code readability reviews. We want to focus on that stuff. Purpose becomes important. And the one that probably most people think about is that portability or reusability. I like the idea of that portability. So we want to design packages that are portable with reusability in mind. But even there, you kind of have to understand the purpose of the package to know what level of reusability matters, right? Not all packages are equal. So there are packages that have to have very high reusability aspects. They almost can only import things from the standard library. There are others that don't need to have that highest level of portability. Policy is a big thing that we'll talk about. Policy is the decisions, the imports, the dependencies, the things that you're saying this package does. They're going to create constraints on other packages that may want to use this one. So policy is a big deal. We got to know when and where we can set policy. And that single point of dependency is always going to be a problem at the end of the day. Maybe not today, maybe not tomorrow, 6 months, a year from now. Eventually, those single points of dependency, those packages that contain and not provide, they are going to cause problems. So these design philosophies, along with the language mechanics, are going to help us really be able to start to question what we're doing in terms of our mental models with our project structures, with our packages, our import paths. We're going to talk about that by sharing a couple of project structures that I think are going to really help you, especially early on, try to stay out of trouble with your applications.